Any questions? I don't know if everybody could hear that. The question was whether we had written a book yet. We have not yet. That's an interesting question. I hadn't thought about that. But okay. The information that is available, we have been making this particular presentation available, and we will make every attempt to do that with this one that we showed tonight. And it is fully our intention to follow on with the building, to monitor it closely through construction, and to get into it afterwards through measurement and verification to make sure that it performs the way we think and hope it will. And if it does, or even if it comes close, we expect to be generating a lot of data for ourselves and for others to try to promote some of these strategies in standard building design. Well, the building is scheduled for completion in the middle of 2009. That's a great question. The question was whether there was any water-saving features, and we did look at a lot of them. There are two issues. One is water is very inexpensive in Guangzhou, and a lot of the water strategies that we did looked at how we would capture water from around the building, capture groundwater, and reuse that. The groundwater quality is so bad there that it was really not practical to. The climate would not even consider any notion where we were looking to capture that water and draw it into the building for health reasons. No, the answer is no. We do not have any water reduction strategies on the project.
What did that cost?
I'm sorry?
Did that cost?
What's the total cost?
Total cost?
Yeah.
Do you remember?
Yeah, it's just under $300 million. Yeah.
$300 million, just under.
Can you talk about the absorption strategies of the radiant cooling? How you got the water chilled in order to get it to a renewable strategy to
The radiant system, more detail about that? Okay. The radiant system, one thing that is unique about it is that we're an air handling unit to generate cold air. We generally use chilled water at about 42 degrees Fahrenheit and pass it through a coil. The air would blow over that coil. The air would then cool down, and that's what gets delivered to the space. We do need chilled water to make a radiant system work. But we need a lot less of it because the cooling loads are a lot less for us. And we can use chilled water that is much warmer. The goal in a radiant sealing system is to get the sealing to be a little bit lower than the temperature of what you're trying to exchange heat with. So we're looking at keeping the sealing at about 70 degrees Fahrenheit. And we can do that with water that is warmer than 60 degrees Fahrenheit. So the chilled water that we do generate is much warmer than a standard system. And again, so the energy that it takes to get it down that cold is a lot less. If you want to talk later, I could go on for another 2 hours just on radiant systems. But I'm sorry. Yes, sir.
I want to know, steel is the outside of the building, right? Steel and glass.
Yes.
What's the difference between using steel and titanium?
Cost. Yeah, it's too costly. Very strong, but it's too costly. So, no, from a structural point of view, I think steel was really our only. We've got some composite structure working there as well as some concrete encased steel work in certain areas of the building. But by and large, it's steel frame. There's another question back.
We did look at the geothermal systems. One of the problems, again, because we are in Guangzhou is fairly close to the equator. It is very warm. The groundwater temperature is about 75 degrees year-round. So the groundwater was really just too warm for us to be able to come up with a a strong business case to use a geothermal system here. So that's one of the reasons why I say if you took this design approach and put it in many other places in the world, you could do this plus more. There are things that just didn't make sense for us to do because of the environmental conditions.
How much electricity do the turbines produce?
The wind turbines? It's not. I'm trying to remember the number in total kilowatt hours. It's a relatively low number. The standard turbines generate about 10,000 kilowatt hours per year per turbine. That's given a wind velocity of just over 5 meters per second on average, which is what we would have at the ground level. When we put them into the openings, the velocity goes way up. And I believe we were coming up with a number in the 40 to 50,000 kilowatt hours per year per turbine range. Now, again, when you add up those four and you look at that amount of energy and you compare it to the total amount of energy that the building consumes, it's still a small number, but it's something. It's one of the 32 things you need to do to get to the maximum performance.
Did you employ LED lighting as well?
We looked at LED lighting. I don't recall why we didn't follow through with it. I honestly think a lot of it has to do with the way that we design buildings right now. The format, that the standard times that are allotted for design and then bidding and construction. I think that part of the overall answer is to rethink that. I think that much more time needs to be given to the front end to be able to properly vet ideas like that and to get them into the design. Because once you put something on paper and it gets priced and that number sticks, to come back after you've gotten through concept design and consider new strategies, it's very, very difficult to do so.
LED might be a good idea.
It might be, yes.
It would be a good idea, yeah. I mean, we're only responsible for the core and shell as well, so we're not doing the full building fit out.
Would new construction around a building like this affect its efficiency?
The new construction around the building will affect the wind and the way that the wind acts around the building. One of the reasons for picking this vertical axis wind type turbine is that it works very good with multi-directional winds. And it according to the literature, we'll see how this works better in turbulent wind flows than it does in laminar air flows. So we don't expect it to have a big impact on the wind. One of the nice things about the site is the area to the south of the site and the area to the east of the site is this new open parkland that they expect to be there for a very long time. So a lot of our sun energy is coming from the south, and the winds are predominantly coming from our south. So we're in a good spot to